Welcome back, everyone. Let's go ahead and talk about example 4. So we want to graph the system of linear inequalities given there. We have x plus 2y is less than or equal to 10, 2x plus y is less than or equal to 14, x is greater than or equal to 0, and our last inequality is y is greater than or equal to 0. Now, let's start off with the bottom two inequalities. I think those will be a little bit easier to deal with, and I'm going to try to color them all differently. So I'm going to use green for x is greater than or equal to 0. Now, the line that we're going to use here would be as if we were graphing the line x equals 0. What does that look like? Well, it's a vertical line, and if that's confusing to you, I will often give students the recommendation of making an XY table to kind of connect some ordered pairs. All of the ordered pairs are going to have an X value of 0. And so if I plotted all of those points, here's 0, 1, 0, 2, 0, 3. Although it's not a function because it wouldn't pass the vertical line test, x equals 0 is a vertical line, and it's actually the y-axis. So here is me graphing that inequality. Now, we can either shade to the left or we can shade to the right. X values being greater than or equal to 0 have to fall on the right side. So remember from the last example, I'm not going to shade it, but I'm going to put in these little arrows to indicate that if I did shade it, I would shade to the right of the y-axis. Okay, let's use purple for us to graph the inequality y is greater than or equal to 0. I forgot to label my axes. That is very important. Okay, so y is greater than or equal to 0. Let's use the same tactic. Maybe I'll use an XY table. So if I were graphing the equation y equals 0, that just means that no matter what I plug in for x, my output would be 0. So if I plotted all of those points and connected them, you'd actually see that the line y equals 0 ends up being our x-axis. And do we shade above or below it? Well, we want greater than or equal to, so we're going to shade above. So if we were only graphing those two inequalities, hopefully you would see that the overlapping shaded region would just be the first quadrant of our xy plane that we have here. Our first quadrant is this area here, so I would shade that in if these were the only two inequalities given, but they're not. We actually have two more that we have to deal with. Okay, so let's now graph the, oh, I forgot to mention, notice that the green and purple lines are both solid because we have greater than or equal to. And notice out of the four inequalities, all of them are actually going to be solid lines because they're all either less than or equal to or greater than or equal to. So I'm going to graph the first inequality in red. It's x plus 2y is less than or equal to 10. And I'm going to solve this inequality for y. So we have 2y is less than or equal to negative x plus 10. And then I'm going to divide both sides by 2. So I get negative 1/2 x plus 5. We're going to find when we graph the next inequality that we have to scale our axes. So each tick mark is going to represent 2 units. So that's going to be 4, 6, 8, 10, 12, 14, 16. So same with this, 4, 6, 8, 10, 12, 14, 16. So each tick mark represents 2 units, and you'll see why when we graph the next inequality. We're not going to have enough space if we make each tick mark 1 unit. So again, I'm graphing my inequality now. Y is less than or equal to -1/2 x plus 5. So that would be right here. Our y-intercept for that one would be 0, 5, and then we'd move down 1 over 2 for our slope, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Okay, so our line is going to look something like that. Okay. This is a long problem. The last inequality I'm going to graph in blue. So I'm going to subtract 2x on both sides, and if I do that, I would get y is less than or equal to -2x plus 14. And this 14 is the reason why we need to scale by 2. Okay, so our y-intercept for this one is 0, 14, so that would be right here. And our slope is -2. So we would go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So our graph would look something. Ooh, my apologies, that's not right. Would look something like that. Okay. Now, my goodness, we need to figure out where we are shading. So I've already gone ahead and done that, and it turns out, I've been doing this for quite some time, so I know that we're going to shade on this side of the red line, and we're going to shade on this side of the blue line. My apologies, I know this is getting quite messy, but I'd like you to pause for a moment, and I'm about to take my highlighter and I'm going to highlight the feasible region. I want you to pause the video for a moment and see if you know where the feasible region is going to be before I highlight it. All right, so hopefully you pause the video. I'm going to go ahead and highlight where all of these 4 inequalities overlap is this region right here. It's in the first quadrant, and it kind of makes it's almost a triangle, but then it gets cut off a little bit by the blue line at the end, so it's not quite a triangle. It is a quadrilateral, but it is this shape here. So remember from a previous video that this area here is called the feasible region.